In this episode, we'll talk about what Go is, why it's exciting, and why it's making such a splash on the programming scene. Welcome to Kopek Explains Software, the podcast where we make computing intelligible. So we're talking about the programming language Go this week. Rebecca, what's the first thing we should probably talk about when we talk about a programming language?
Who created it?
Yeah, I think it's nice to start from the beginning. So Go was created in 2009 as a project at Google. It was a veteran design team, folks who had really had a lot of experience in language design. If you know a lot about programming languages, then you've probably heard the name Rob Pike before. He's been involved in the design of several different languages. And some of the folks who were actually involved in the design of C, and we've done a previous episode on the C programming language that I'll link to in the show notes, but Ken Thompson was actually involved in the design of Go. And Ken Thompson, of course, is a legend in the world of computer science and software technology more generally. Even somebody like Brian Kernighan, also very famous in the world of computer science and associated with Ken Thompson quite a bit, has been involved in Go in that he wrote one of the definitive books on the Go programming language. So there's a lot of kind of old hats in programming language design who've been involved in Go. Folks who worked previously on languages like C and awk and other well-known languages from kind of the Unix family of programming languages.
So why did they decide to go ahead and develop a new programming language?
Well, these talented veteran designers had some issues with the direction that some mainstream languages were going. Now, clearly, a lot of these folks came from the Unix world, and they were heavily inspired by C. The successor language to C, of course, is C++, and they were explicitly not fans of C++. In fact, they cited not being happy with C++ as one of the reasons that they designed Go. So Go is a successor to C in many ways, but not a successor to C++. There was another motivation too, and it's in the programming language's name. In Go, when you want to start what's called a Go routine, which is a concurrent function, you can do that by using the Go keyword. Go was designed from the beginning for concurrency, for a world where microprocessors have multiple cores, and being able to do more than one thing at the same time or do something asynchronous is extremely important, so important that it should be at the core of new programming languages. The designers of Go wanted a successor language to C that didn't do some of the things they didn't like about C++, which we could all summarize as becoming overly complicated. And they also wanted a language that was natively designed for concurrency and for the world of modern microprocessors that have many cores. Being turned off by C++, they went the opposite direction. While C++ is this huge kitchen sink language with a ton of different features and many different ways to do things. And by the way, we did a previous episode on C++ that I'll link to in the show notes. The Go designers wanted a very simple language, more akin to C, which is a fairly simple language. In fact, the original version of Go had only 23 keywords. And I should mention, when I say original version, Go has actually been incredibly stable over the last 15 years. Since the language first came out, you can pretty much take code that was written in the original version and compile it in the current version of Go with very few or no changes. The biggest addition that's happened to Go is they added generics. The original version of the language had no generics, but that's the only real big change that's happened to the language since it first came out all the way back in 2009. Speaking of their hatred of C++, I actually have a little quote here from an interview between Ken Thompson, one of the designers of Go, and Dr. Dobbs' Journal, which was a popular programming publication that unfortunately is no longer around. So Rebecca, I'm going to play the part of Ken Thompson, and you play the part of the interviewer from Dr. Dobbs' Journal. And I'll start because actually a little snippet I have starts with Ken Thompson. He was responding to a question. He said, "Yes, when the three of us, Thompson, Rob Pike, and Robert Griesemer, got started, it was pure research. The three of us got together and decided that we hated C++.
I think there'd be a lot of people who are with you on that.
It's too complex. And going back, if we'd thought of it, we'd have done an object-oriented version of C back in the old days."
You're saying you would have?
Yes, but we were not evangelists of object orientation. We started off with the idea that all three of us had to be talked into every feature in the language, so there was no extraneous garbage put into the language for any reason.
It's a lean language indeed.
What this passage is referring to is the fact that they thought C++ was just too big of a language. It's got too much going on. There's a saying in industry that nobody learns all of C++ or uses all of C++. Everyone uses their own subset of C++ because it's such a big language. And that's clearly what these three designers of Go felt. And so they really wanted to do a language that had some of the benefits of C++. They specifically mentioned object orientation. We'll actually come back to that because Go is not really thought of as an object-oriented language, but it has some features from object-oriented languages. But at the same time, they wanted something that was still small and simple enough that it's more comparable to C, meaning that anybody can really learn all of it who's an experienced programmer in a relatively short amount of time and know everything they can do with the language. And I have to say, personally, that appeals to me. I like languages where I can keep all of the language in my mind at any given time.
So originally, Go was seen as this replacement or improvement for C, C++, but really that's not who it's replacing.
That's right, yeah. So they thought they were writing a successor to C, and they thought hopefully that some people that didn't like C++ would also like it. But actually, more often in practice, what's happening is Go is replacing languages like Python, JavaScript, Ruby, and Java. The reason being is that Go is being used often for server-side web development or other kinds of server-side work, such as network server infrastructure projects. It has those great concurrency primitives built in. And of course, when you're writing a server, having great concurrency is critical. And so Go is much faster than Python, for example, or Ruby, for example, or even JavaScript. And that means that you can take Go and replace the equivalent Python project with a Go project, and you're going to cut down on your hardware needs quite substantially. If this is something that wasn't scaling well with Python because Python's so slow, you convert it over to Go, and suddenly you're going to get a much better performance story. But on top of that, because it has great concurrency primitives built in, you're also going to get a much better concurrency story. Taking Python specifically, we know that Python has had issues with concurrency throughout the entire history of the language. They've tried to improve that recently with async await, but there's still problems like the GIL, and they're trying to work on them and make Python a better language for concurrency, but it's not there yet. Go was designed from the ground up to be a good language for concurrency. And when you're doing something that's server-side, concurrency is critical. That's the niche that Go has really found. It's found its way as a great language for doing server-side web development or other kinds of network server infrastructure projects. They thought it was going to be used in the same places as C or C++, because that's a world that the designers were coming from. They thought it was going to be used for things like operating system development or maybe some desktop app development. That's C++ is used for that quite a bit, right? But actually Go hasn't really made much inroads into either of those spaces. It's not quite as performant as C or C++, and we'll talk more about some of the performance shortcomings later on, but it is much more performant than a Python or a Ruby.
Let's talk through some more of the characteristics of Go.
Sure, and I'm going to assume that a lot of the terminology here is understood by our listeners, but if some of this doesn't make sense, there's a previous episode called What is a Programming Language that I'm going to link to in the show notes that goes over a lot more of these programming language characteristics. So Go is an imperative or procedural language. Those are the paradigms that we would put it within. In that earlier snippet, Ken Thompson talked about they would have done an object-oriented version of C earlier on if they had thought about it, and this was in the context of talking about Go. But most people don't really think about Go as an object-oriented language. There aren't classes, there isn't inheritance, there is a way of adding methods to structs, but that's about as far as it goes in what we classically think about as objects. So because there's no inheritance, there's no class hierarchies, and there's not really polymorphism in the same way that we would expect in a language like C++, we don't really think about Go as an object-oriented language. We think about it as a procedural language that happens to have the ability to add procedures to structs, which makes those structs a little bit more object-like, but doesn't really make the whole language object-oriented. Go is ahead of time compiled, so it's not interpreted like Python or Ruby. It's not just-in-time compiled like Java or JavaScript. It is ahead of time compiled, which tends to be a performance advantage. It's statically typed. It's garbage collected, which I've already mentioned before, meaning that you don't have to worry about memory management too much when you're programming in Go. You don't have to remember to delete the memory that you've allocated. Of course, it has those great concurrency primitives built in, those Go routines, which come with another helper construct called channels that allows you to communicate across Go routines. And Go has all the things we expect in a modern language today, like it has a built-in package manager, it's open source, it has syntax that's pretty modern with things like type inference, and it has a huge standard library. So a few of those things really separate it from the language that its designers were inspired by, which is C. So even though Go has kind of C-like syntax, it has a garbage collector, whereas C didn't. It has a built-in package manager, whereas C didn't. It has modern syntax, which of course C doesn't. And it has these concurrency primitives built in, which of course C doesn't. So it really removes a lot of the flaws and problematic parts of dealing with C. What are the downsides? The biggest downside is it's not quite as fast as C. When I've looked at current benchmarks, it's about 2 times slower than C. Now remember, Python in many benchmarks is as much as 50 times slower than C. So while it's slower than C, for a lot of the applications that it's replacing, which are written in things like Python or Ruby or Java, Go can actually be quite a bit faster. I'd like to dive into a couple of these characteristics that are somewhat unique. Most importantly, the concurrency primitives. So Go has language level support for concurrency, whereas a lot of languages like C or C++ leave concurrency up to the operating system and libraries like pthreads. Go, from the beginning, was thinking about concurrency. Now, it's not like other languages haven't done that. Even Java, which we now think about as an older language, even though in the lifetime of programming languages, it's not that old. But when Java came out in 1975, they thought about having keywords that were specific to concurrency. They had concurrency primitives built into the language, things like the synchronize keyword, for those of you that have used Java. So it's not like nobody else ever thought about this, but Go was designed from the beginning to have really lightweight concurrency. It's a single keyword. You use the keyword Go and you say the call of the function that you want to start. And then Go launches what would be thought about as a green thread or a very lightweight thread. It's called a Go routine in Go that will concurrently run just for that function for the lifetime of that function. And that makes doing concurrent programming a lot easier. It's super easy to launch a concurrent Go routine. And then once you have that concurrent Go routine, it's really easy to communicate with it because you have these things called channels. A channel is a way for one Go routine to communicate with another without using shared memory. Instead, a channel passages messages, which are really just fully formed objects with values, back and forth across the channel. So you're always copying something across the channel instead of having shared memory and all the errors that come with shared memory. This is a different model than async await. We've seen Python, JavaScript, C# all adopt async await, and actually most recently Swift when we think about mainstream languages. But Go routines are really you can be thought about as lightweight threads. And so you don't have to go color your functions, say that this function is going to be async, this function is not going to be async. Any function can be launched as a Go routine, and you just program that function as you would any other function. So it actually is a lot less ceremony than dealing with async await. And you have these beautiful channels to deal with managing data across the chasm that is one Go routine to another. I personally like Go routines and channels. Some people like async await better, but I find it easier to reason about not having to have some functions in the async world and some functions outside the async world. I also would like to talk a little bit more about performance. So when we say that Go is about 2 times slower than C or C++ in a lot of benchmarks, that puts it in the same performance category as Java and Swift on a lot of those kind of benchmarks. So that's comparable to other modern languages and not comparable to something like Python or Ruby, which are way out there, about 50 times slower than C on many benchmarks. But benchmarks aren't the only way that we think about programming language performance. We also should think about how productive is the programmer in this language. By being a very simple language, I would say that the average programmer is going to be more productive in Go than they are in C++, unless they're really a C++ expert who's been doing C++ for many years. So I think you need to take that in consideration as well. It depends where you're coming from and when you go to Go. and that's going to have a big impact on whether you can actually have your team be more productive in it. But when we think about performance, we always have to balance it with the performance of the programmers, the programmer productivity. And I think Go was really designed to be a productive language for programmers. I don't think Go will ever be quite as performant as C or C++, just like Swift and Java will never be quite as performant as C or C++, because they're not quite as low level. They're working at a higher level of abstraction. In Go's case, it has a garbage collector. Languages with garbage collection are never going to quite achieve the same level of fine-tuned performance as a language that uses manual memory management might. So I think Go's performance will probably continue to improve. Of course, the compilers for Go are much younger than the compilers for C and C++, so there's more optimizations to be made. But it's unlikely it'll ever quite reach C and C++ levels of performance. And maybe that's okay, because we're trading that for a lot of these more modern features, and we're also trading that for some more safety. Go is in general a safer language than C or C++ because it has things like a garbage collector and things like safer concurrency mechanisms. While we might not quite achieve C or C++ performance, we hopefully have less errors and less security vulnerabilities. The syntax of Go I called before C-like because obviously being designed by the designers of C, or people who are at least very much in the C world. Ken Thompson was one of the folks who was really involved in the origins of C, but all the other folks were really in the C world. They were influenced by C syntax quite a bit. They made some changes, but if you're somebody familiar with any of the C family of languages, that's C, C++, Java, JavaScript, etc., you'll be comfortable learning Go. And you'll get used to Go pretty quickly. And because Go only has 23 keywords, even though it's kind of an opinionated language from a syntactic perspective, it doesn't take very long to learn it for experienced programmers.
Talk to us about the standard library for Go.
Yeah, I mentioned earlier that one of the things that makes it modern is it has a big standard library. And I think that's really in opposition to C, which again is kind of the goalpost that we're comparing against when we talk about Go because of where Go came from. C has a tiny standard library. When you program in C, it's like everybody is writing their own string struct, and everybody is going and re-implementing basic algorithms and data structures like how to do a hash table, because they're not in the C standard library. But Go has a batteries included standard library, like Python or Java, meaning that there's everything from image manipulation to an HTTP server right there in the Go standard library. So I like that because I don't want to reinvent the wheel every time I program. While Go still has the simplicity of C, we have a lot of basic data structures and algorithms right there in the standard library that we can reach for, and even some higher level constructs that just make day-to-day life easier because we don't have to go find a third-party library for absolutely everything that we want to do. The standard library itself is very heavy around slices, which can really be thought of as a type of dynamic array, and dictionaries, which are also known as maps or associative arrays in some other languages. So both of those data structures feature quite prominently within Go standard library and the way that Go is used in practice.
So why has Go been so popular amongst Python programmers?
Yeah, I think the two reasons are, one, it's much more performant, and two, it fits better in some of the niches that Python has been being used in. Well, Python has found incredible success in places like server-side web programming with frameworks like Django and Flask. Go, with its built-in concurrency mechanisms and its much higher performance, is really a language that was almost made for the server side. And so for folks who are using Python for server-side development, Go can make a lot of sense from a performance and concurrency perspective.
We touched on this, but why were the creators of Go so unhappy with C++?
Yeah, they just found it too complicated. They were coming from that original C mindset, and they thought C++ went off in so many different directions and was trying to do so much that it was actually too much. And they wanted a simple language, a language that people could keep in the entire language in their mind at any given time. And C++ is definitely not that. So they had their critiques of C++. I think their critiques went beyond that. But if we had to just summarize it, we would say that they thought C++ was too complicated.
And last but not least, what do you find surprising about Go?
Well, I don't really find anything surprising about Go. And I think that's one of the things that's surprising about it, is they didn't try to do too much. When a lot of new languages come out, they try to have some kind of overriding theme or something that's really like new and exciting and different about the language. Go is kind of a boring language, and that's actually what's surprising for a new language to do. Instead, they wanted to fix the warts in C, and they wanted to create a language that had some obvious things that any modern language needs to have. The thing that they really put a lot of thought and dedication into, and it's why it's the name of the language, is the concurrency primitives. And I think they did a great job with that. But at the same time, they didn't really surprise us in any other ways. It's a boring language. It's a language that, because it's boring and relatively simple, is easy to pick up. If you already know how to program basically any other language, you can learn Go pretty quickly. There's nothing there that's really going to surprise you. And that in and of itself, being a new language, and I mean relatively new, 15 years in the life of programming languages is pretty young, is in and of itself surprising. Thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you in 2 weeks.
Bye.